So today, let's talk about functions specifically, okay? And it is 5:30:18. We're almost there. So, let's take a look. Here's a graph that represents a ride in a car. So tell me what's going on. So, right here, okay, let's just say we're at home. Girls, are you listening? So tell me, if you were to tell me and describe, in your words, what would you see? Natalie, what do you see? You're taking a car trip, and this is your trip. What do you see? This is, okay, a line. Well, tell me, you hop in your car, and what do you see? Seriously, what do you see? It's not that hard. So you hop in your car, what do you see?
Hills. There's an increase and a decrease of the speed.
Good. So you're taking off, man, you're hopping in your car, you're going, whoa, right? So, you're like accelerating, right? So this is like, maybe one of those like really speeding drivers, because that's pretty fast. That's pretty quick rate.
No, you get to 40 miles an hour in 10 minutes.
Well, all right. That's probably true also. So it's a gradual. I'll go along with Claire. So you're getting up, and then you're 40 miles an hour. And then what happens when you hit 40? So you're probably on some kind of a freeway or an arterial where the speed limit is 40, right? And then what happens? Slow down. But have you ever stopped? No, because your rate is now at 20 miles per hour. Then what happens?
Speed up again.
Speed up again, and then you get all the way up to 60, right? Okay. Now what happens right here? You stop. You're stopped, right? Children, shh, stop talking. You're stopped, right? And you stop for a while. It could be a stoplight or something, and then you speed up again. So I would write something like this, that you're basically heading to a arterial. So you're from home, that's home. I head to, probably like an arterial. That goes about 40 miles per hour. So that's your arterial, going about 40 miles per hour. Then you are going to slow down. And what I see, this part is like getting ready to go on at the freeway ramp, right? Slow down because you got to slow down. Maybe going around one of those little roundabouts, whatever. And then you speed up, and right here you're on the highway, right? Highway, and then you're on the highway for about, girls, I can send you outside easily because I need to teach, other kids need to learn, okay? So I'll be on the highway for about 20 minutes, 25 minutes, and then I'm going to slow down to a stop, right? So I'm going off the highway, come to a stop, and it could be a stop sign. This is probably a stop sign or a stop light. Probably a stop light because you're there for a while, stop light. It might even be longer. You might even get out of your car. It looks like about 10 minutes. Maybe I have to go to the bathroom. I'm on the highway, and I got to go to the bathroom, so I take a real quick off ramp. I go to the bathroom for 10 minutes, then I start heading back to the highway, right? Does that make sense? That's how I would describe it, okay? All right, let's look at example 2. So make a scatter plot. Okay, I can do that.
Okay.
So I've got laps, and I've got time in minutes. So I've got 2 laps, 13. So I can put a scatter plot at 13, 4, and I go 16. Let's see, that's 10, 12, 14, 16. 6 and 19, so 19 is right there. 8 and 22, 22 is right about there. Thank you. And then 10 and 25, so I've got 20, 22, 24, 25. Now, if I look at my graph, does it look straight? Does it look straight? Right? Guys, it looks pretty straight, so we're going to say it's linear, right?
Oh, there they go.
The girls? I'm not supposed to. I'll deal with it later. So it's supposed to be linear, right? So if it's linear, it's a straight line. We can probably connect the dots, right? And if we needed the equation of this line, then first let's find the slope, right? Because the equation of y equals mx plus b is the equation we need. It's linear, right? So let's get the slope, and we pick any 2 points for slope. any 2 points. Let's pick the first 2 points, all right? If I need slope formula is y2 minus y1 over x2 minus x1, right? So my y2 is 16 minus my y1 is 13 over x2, which is 4, x1 is 2. So I get an answer of 3 over 2, or 1.5. 3 over 2 is my slope, right? So the next thing I need after I get the slope is I need the y-intercept. I need to find b, which is the y-intercept, okay? And I can just use the formula y equals mx plus b. I know the slope is m is 3/2, it goes right here. This is just algebra 1. You guys learned this in algebra 1. And I can pick any point on the graph I want for some x and y value. I may as well use the 2 and 13 because those are small numbers. That's an x and that's y. So to find b, I'm going to take my 13 is equal to 3/2 times my 2 plus b, right? Yeah, 13 equals 3 plus b, or b equals 10. So my equation is going to be y equals 3/2 x plus 10. And I'll let you catch up, right? Now, how long will it take to run the 20 laps? We'll just use our equation. So we're going to plug in 20, okay? So I'm going to go y equals 3/2 times 20 plus 10. So let's see, the 60 divided by 2 is 30, plus 10 is going to be 40 minutes. Okay, easy. This is just basically algebra 1 stuff. Just a review. That's pretty easy. Everybody agree? We know how to do this. We know how to do slope. We know how to do equation of line, right? Thumbs up?
Yes.
We've done this before, okay? Turn the page. Okay. Now, this one's different. So the owner of an orange grove finds that there's 26 trees are planted per acre, okay? Each tree will yield about 576 oranges, okay? For each additional tree planted, the number of trees decreases by 12. It gets scattered, which is weird because they get crowded, right? So it increases. That doesn't make sense. Let's graph
What
it.
does that even mean?
It should be increases. That must be a typo. That's a typo by me. It's got to be a typo, huh?
No. Although, wait.
Why would trees decrease?
That is my typo, huh?
Do you mean oranges?
Oranges, yeah.
Wait, which one is wrong? The decreasing one? Or
For each additional tree planted, the number of oranges increases by 12, right? Oranges per tree. This should be, I need to retype. Well, it doesn't really matter because I'm going to go to a new book next
Wait,
year.
the oranges per tree decreased by 12?
Yeah, that's what I think it is, isn't it? The decrease is right. You just put trees instead of oranges.
Oranges. Okay, let's graph it. 26 and oranges, total oranges, right? Yeah, that actually should have said oranges. Let's graph it anyway, okay? 576. So we're going to go 14,000. Right about 15,000. Let's see, 14, 15, 16. So it's got to be a 14, 500, 16. 1,400, 1,500, right? 15,000. 16,000, 16. This is 15,500. Boy, I should have looked at my notes this morning. I was going to, except for then I had a faculty meeting, right? 16,500. That's all right. We'll make it work. So here's 26 and almost 15,000, which is about there. All right. 27. Here's 27. About 15,228. 15,228 might be about there. Yeah, maybe about there. 28 trees would be a 15,400, maybe about there. 540, so I've got 29 trees, so that's 29 trees. About 15,600. 30 trees. Sorry, Katie, I'll move it over. 30 trees, it's got to be about 15,800, maybe about here. 31 trees is here, about almost 16,000 right there. 32 trees is here and about 16,100, okay? Alright. Now it doesn't quite look like it's straight to me, right? In fact, it looks like it's going to curve. And probably, as I keep adding trees and adding trees and adding trees, the orchard's going to get crowded, right? We're not going to have as good of a crop. So I think this is going to be a quadratic model, okay? So if it's a quadratic model, we're going to have some y equals ax squared plus bx plus c, all right? All right, we're going to go back and use our calculator. And we've done this before, but I'll go through it with you. So the two columns I want to use are the trees and the total oranges, right? So if you need a calculator, grab a calculator because you're going to need the stats, okay? Here you go, Claire. Okay, here. There you go.
I got one.
Boys, you need a calculator?
Yes.
Here's one just in case you are paying attention. Okay. Girls. Guys. Well, okay. So, let's go back through this. So we need to go to, and I'll write it down. If you want to write this, you can. So let's go to stat. First thing, remember doing this before? We have done this before. So go to stat. Turn on stat. Stat, okay? Go to stat. You will remember edit, correct. Okay, list one, right? So we're going to enter data. We're going to go list one. So I'm going to first of all clear my list one. Remember how to clear it? Clear. Go back up, hit clear and down, right? So I'm going to go 26, 27, 28, 29, 30, 31, 32, okay? List 2, oh, 14,976, 15,228, 15,456, 15,660, 15,840, 15,996, 16,128, okay? So I've got it all in there. Then we're going to go back to stat again. Remember? We're going to go back to stat. But before you do that, everybody got it all in? I'll wait for you. Okay, we'll go to stat. And this time we'll go over to calculate, right? To calc. Quad reg. Remember quad reg? Quad reg. L1, remember L1? L1 comma, you got to put the comma in there. L2, L1, comma, L2, right?
Wait, where's the comma?
It's right above the 7. Right above the 7. Do you see it? Right above the 7.
Oh,
Yeah.
thank you.
You're welcome. Enter, and I get this answer. So here's what we know. A, B, and C, right? Want me to back up? Yeah, I'll back up. Stat, calculate, go to quad reg, enter, L1, so you gotta go L1, comma, L2, okay? Got it? Everybody got it? Enter. So it gives me this y equals ax squared plus bx plus c, but we know what a, b, and c happens to be, okay? So I'm going to go y equals a negative 12x squared plus 188, sorry, 888x plus 0, okay? Now, how do we find the maximum number of trees to plant? Well, that would be our vertex, right? And to find the vertex, we're going to use that negative b over 2a, right? Remember how we did that? So the vertex is found by using negative b over 2a, which would be a negative 888 divided by 2 times negative 12. And I get an answer of 37 trees. Okay, now I've got 1 to 14 odd. Now I know that says 14, I changed it, so let's change that to 1 to 13, because like Claire said, we got to cut down the homework
Cut the homework down.
significantly from all to odd.
Oh, wait, no, you changed it to 13.
Wait, what did you
14,
do?
we had it on odd, and I was
But
like,
it was.
Change anything.
No, 31 and then 34. So